Good afternoon, everyone. Today I will be sharing with you about my research project on the new novel solid electrolyte that is used for high voltage battery appliances. But before I dive into what is my research about, let me actually go back into history to share with you a bit about the evolution of battery. Ever since the first design of the voltaic cell in the 1800s, our battery has become much more compact and smaller. But the battery has been able to provide a higher energy capacity and also more power. And the use of battery is basically in most of our daily appliances and has really brought a tremendous amount of ease to our daily lives. However, although there's this evolution of batteries has never really ran away from the fundamental design. And this involves the use of the electrode, which is the cathode and the anode, and also the electrolyte. The electrolyte is a liquid chemical that is within the matrix of the battery that facilitates the conduction of ion and electron. And in common battery appliances today, the electrolyte used is potassium hydroxide. However, one drawback of our battery is that there's often battery leakage involved. And what causes battery leakage? Battery leakage happens when the potassium hydroxide reacts with the electrodes during the electrical discharge that produces hydrogen gas. And when there's this buildup of hydrogen gas, it results in a pressure buildup within the battery. And when the pressure is too high, the battery will explode and then causes the chemical within to leak out. And this chemical leakage can result in chemical burn of the user and also poisoning. And in the worst case scenario, fire. And we have seen many cases where battery leakage results in fire that causes huge damage in properties and also the lives of people. And in order for us to mitigate this challenge, we have actually proposed the design of a new electrolyte, a solid electrolyte. By using a solid electrolyte, we actually reduces the chance of battery leakage, as there will be no gaseous buildup during the chemical discharge, during the electricity discharge of the battery. Okay. And also, the solid electrolyte allows the fast charging, meaning that our battery can be charged at a shorter duration of time, but being able to last longer during our usage. And by using the solid electrolyte, the battery will not be flammable anymore, and this actually prevents the chance of it catching fire and causes damage to our properties. And also by using this new solid electrolyte, we actually increase the energy density of our battery, meaning that for the same design of a battery which has the same volume, by using a liquid electrolyte and a solid electrolyte, the one that has the solid electrolyte will be able to hold more power and therefore allow us to use for a longer duration. And also, the use of solid electrolyte allows for simple fabrication, as we can just do a simple thin film deposition in between the two electrodes. As you can see from this diagram, where the solid electrolyte is sandwiched between the anode and the cathode. And with this new design of solid electrolyte, it will actually help improve in the daily appliances of our battery usage. But before we can do that, we need to put a few considerations into the design of this new solid electrolyte. First being that the range of the solid electrolyte must have a huge chemical reaction potential range, meaning that it allows for the usage of different electrodes during the chemical reaction. Next, it cannot have any side reaction, meaning that the electrolyte cannot react with other parts of the battery, and this will result in the dysfunction of the battery. And also, the solid electrolyte need to have a high dielectric constant that actually improves the capacity of the battery, meaning that it can hold more power and allow for longer duration of discharge. And it needs to have good ion conductivity to facilitate between the conduction of the electrons and the ions between the cathode and the anode. And lastly, ion mobility. And with this new design in mind, we actually can see from the graph that solid electrolyte given at room temperature will have a higher charge capacity as compared to other liquid electrolyte at the bottom. And this graph shows that with this new proposed idea, we'll be able to improve the use of our new design battery with the solid electrolyte in place. Thank you.